In this question, it is given that Mars has a diameter of approximately 0.5 of that of Earth. So diameter of Mars is 0.5 of diameter of Earth, or we know that if you are dividing this by 2, diameter by 2 is nothing but radius, or you can write radius of Mars is 0.5 times the radius of Earth. And it is given that the mass of 0.1 that of Earth. So mass of that Mars is 0.1 times that of mass of Earth. So we know these two information. Take it as equation number 1 and equation number 2. The surface gravitational field strength, that means nothing but acceleration due to gravity on the surface on Mars as compared to that of Earth, is greater by a factor. So we can just find out what about the relation between their acceleration due to gravity on the surface. We know that acceleration due to gravity is gm divided by r square, or acceleration due to gravity is directly proportional to m divided by r square. So you can write acceleration due to gravity on Mars by acceleration due to gravity on Earth is equal to mass of Mars divided by mass of Earth into radius of Earth divided by radius of Mars the whole square. Now we can just substitute this value. So let's see, from the first relation we can write the radius of Earth divided by radius of Mars is equal to 1 divided by 0.5. 1 by 0.5 is nothing but 2. So we can write this as radius of Earth by radius of Mars is 2. So it is 2 square into, from the second relation we can write the mass of Mars divided by mass of Earth is equal to 0.1. So we can write this as into 0.1. So we can write acceleration due to gravity of Mars by acceleration due to gravity of Earth is equal to 0.1 into the square of 2, which is nothing but 4. So 4 into 0.1 we can take it as 0.4. So acceleration due to gravity on Mars is 0.4 times greater than acceleration due to gravity on Earth.